Hello guys, today we're going to have a look at a Tamiya motor gearbox. This is a 12-speed gearbox, so you can have 12 different gear ratios that you can choose from. It's model number 70190 and we're going to possibly use it in the Liebherr model. I think the motor should fit easily enough between the two front wheels here. So today we're going to assemble it, and in a video later on related to the Liebherr model you will see the installation of the motor in the model, so make sure and subscribe so you don't miss out on that. Okay, so let's see what's in our box here. As with the other Tamiya motors, we have plastic molded parts, or clear plastic molded parts, instructions. We have some grease and screws and a couple of Allen keys. There's our little motor, looks to be the same as in the other Tamiya motors that we've used before. And the final little thing is our little set of gears. So it looks to be mostly the same components as the Mini Motor Gearbox. So Tamiya probably mould a lot of these parts for the different models and just combine them in different ways. So let's see if our instructions are. They're all in Japanese, but it's all pretty clear. I mean, you have your instructions are all just diagrams. It's quite easy to follow. It says we need recommended tools. Oh, sorry, I made a mistake. It's not all in Japanese, there's Japanese and English. So we have recommended tools. We need our pliers, tweezers, a model knife and a screwdriver. So you can see here are our different gear ratios. So we can go from about 1300 revolutions per minute to 30 revolutions per minute. Okay, so the first thing we're going to want to do is take our gears and find the ones that we're going to need. We don't use all the gears that's in the kit, but it tells us in the instructions which ones we're going to need. So we will need one of these pinion gears. Oh, we'll take that out, and in the instructions it says to just take the little edges off the gear so that you don't get caught in anything. So you do that with your little knife, just do that carefully. Okay, then you want your motor. First step, and we just put our pinion gear on. We need to push it down, we need to apply a bit of force to get this on. That's the pinion gear on our motor. So the next thing we need to do is break out our kind of motor housing. Make this part next, and again we'll just tidy it up a bit. Okay, so we need to push our little brass eyelets in first. So you put all 4 of them in, and just 2 goes into a tighter space on this side, so we're going to need our tweezers for that. Put them in there. Push them in. The video you've watched up to this point was actually recorded a few months ago. I think at the time the camera done something funny. I think it just let me down, so I kind of got fed up with it and built the motor thinking that I'll just take it apart and reshoot the video, and I never got around to it. So today I'm just going to finish that off. I'm telling you that because when I tried to take the motor apart, I discovered that it's actually a little bit harder than you might think. So when I left off recording this, I had just put in these eyelets. The next step was to put these end pieces on the side of the motor and then put in this part of the gear train. So you can see there's 6 gears in there of the gear train. So all you do is put on one of these end pieces, put the shaft through the other side and get your gears on it. The same for the 2 shafts really, and then you put the end piece on here. Now I've found that getting the end piece back off is actually quite difficult, so you probably want to make sure that you have the gears 100% correct before you close this up. Now that said, when it comes around to say you might break one of these gears, because they are only plastic gears, so it is possible that you'd break the gears if you tried to push something too heavy. And if you did do that, you could probably get this off with a blade, but I'm not going to bother because you can follow the instructions to build it anyway, so you know what you're doing. So once you have your gear train in, the next thing you need to do is put in this small little gear here, and that is going to mate to the motor. So the motor is next. Now that's our gear train complete up to these gears. This is a 12-speed gearbox, so you've got a choice of 12 different gear ratios, but they're split into 2 groups of 6. So how you select, we'll say group A or group B, is by selecting the different pinion gear for the motor. Now the difference in the pinion gears is that one has 9 teeth and the other has 10 teeth. I've picked the 10 teeth for no particular reason. I don't really need a particular RPM, so I'm just going to go with the 10 teeth, and I'll pick the RPM I need from the other gears here, the 6 options that I'll have once I've built the motor. But so that you know that how you select between each group is you choose the different pinion gear. Now there's 2 tables in your manual that comes with your motor. So you see here you have a table of torques and RPM for each gear set that you choose. So that's kind of an important thing to take a look at. You get a little thing of grease with your motor here, so make sure and put plenty of grease. I've already done this, so there's probably nothing left in here. Oh, there is a bit. So put a bit of grease on everything. It won't do it any harm. It should help with well, it'll reduce the load on the motor for a start, which is always good. So no problem putting plenty of that on there. Once you have your grease on, you're going to want to put the cover on. This bit of plastic sticking out here, that holds the gear to the motor, and this bit holds the motor down. So we need to put that on before we can try to spread the grease around a bit. So we can just start to hold the top on and spin the motor a little bit. Okay, so once you've spun the motor a little bit, you can just lift back up the cap here and just check that the grease has spread around nicely. There's no dry looking gears or anything like that. So mine looks okay, so I'm just going to close that up next as we're finished with this side of the motor. Okay, that's that closed up. So next thing we need is an axle, which comes in your kit, and we need to select a gear. So I told you earlier how to select between the 2 different groups of 6 gear ratios, and now I'll show you how to choose from 1 to 6 in the particular group that you've chosen. So you've chosen your pinion gear now, and you've installed your motor, so you've 6 options. Your gear train is starting here, so this first motor here, the lower one, that is going to be the fastest motor. Then it move up to this one above it, which will be the second fastest, third fastest, fourth fastest, fifth fastest, and the slowest gear. Now the slowest gear is going to give you the most torque. The fastest gear is going to give you the lowest amount of torque. All you need to do to select the speed or the torque that you want is just to place your gear in here, the one with the hex center on it. So this gear fits on the hex shaft. You put that in wherever you want. So I've chosen should be the fastest speed here. Then we have a little thing here to lock the axle in place. So this little brass coupling has an Allen bolt in it, and you just tighten that down on a flat surface on the hex shaft, and that is our gearbox chosen. If I get a wheel for this, we can see the speeds. Okay, I don't have a wheel, but I've put a bit of tape on the axle here, so you should be able to see that spinning around. So because I've put this closer to the motor on the gear train, this should be the fastest setting for this gear ratio. So as you can see, that is going around very quickly. That would probably be way too fast for especially for RC excavator. So we'll spin it on another little bit so that I can get the hex shaft off. Okay. So just loosen this off. We want to change our gear speed. So we're going to try the lowest gear speed now, which is actually up on the top here. So that's the furthest gear away from the motor. Furthest gear in the gear train away from the motor. So this should be the highest torque and the slowest speed. That's the highest torque and the slowest speed for the pinion gear that I chose. So if you choose the other gear here, you'll obviously get different speeds. Maybe it's faster or slower, I'm not sure which is which. So there you go. That's clearly a lot slower than the other gear setup. So it's very simple to just change these gears. You just have to move this gear in line with whichever one that you need. So that means if you set up your model and then say you're not happy with the speed that it's moving, you just move it over this direction, so closer to the motor. If you need more torque and you don't mind going a bit slower, just move it this direction, so further away from the motor along the gear train. So it's pretty straightforward. I quite like these motors. I did ring the gears off some of the other ones before, so we'll have to see how this works out. Hopefully this motor will last in the Liebherr model, but if it doesn't, I can always replace it later on with a CQ Control 32 motor or something like that. It's just nice to have this option to change the speed if I wanted it. The final little piece that's important for this motor are these little mounting posts. So there's a slot on the side of the model here, so you just push that little mounting post into the slot on each side, and then when you get to your model and you drill the two holes in here, because these can't move, the model will be held in place. So without being screwed to anything, they seem pretty flimsy, but once you have them screwed in place, that motor is not going to move anywhere. That'll be important when we come to mount this to the Liebherr model. That should help to make things a lot easier. I'm pretty sure this is the length of axle that came with this 12-speed motor, but if you need longer axles, there are Tamiya kits that you can buy with these longer axles. I bought this for the John Deere with the 4 wheels because it obviously needed much longer axles, and it works pretty well. This is probably what I'm going to have to use for the Liebherr model as well. I'm not 100% certain. I might just be able to use this shorter shaft, which I will do if I can, but if that doesn't work, I'll have to cut this hex shaft to length. I haven't looked on eBay myself for hex shaft, but the reason I think you might be able to find it is if you remember this motor from the eBay motor review, it has a 3mm hex shaft. In fact, this one is probably long enough for the Liebherr model. So if you're having difficulty finding a hex shaft long enough, you might just consider buying one of these. I can't remember how much this was, probably $1 or $2, something like that. It's a pretty cheap motor, but you could buy it just for the hex shaft if that's what you wanted. actually this might be a cheaper option than buying the Tamiya kit, because the Tamiya kit was pretty expensive, I think. So that's another option. You could buy one of these just to get the hex shaft. So that's all there really is to the Tamiya 12-speed gear motors. If you like that video, make sure and give it a thumbs up, and if you want to see this being mounted on the Liebherr, make sure to hit the subscribe button. I'd say the next video I'll probably mount this motor on the undercarriage of the Liebherr. I don't think that'll be too big of a job, so I'll probably be able to start working on the steering for the Liebherr in the same video. So I guess that the next video will include this mounting and starting on the steering. If you have any questions about this motor or any part of the build, you can just head over to the forum and ask a question there. There's no problem. I'll try and answer them if I can. That's everything, so thanks very much for watching.